The agents are from Microsoft if you are using the shared ones. Microsoft is giving you a server where there are all in predefined and installed environment. Okay, the all the softwares that are needed for running your jobs within the pipeline is already there. You do not need to have any customized one. It is all there. If you are running Java programs within the build, so the Java that Maven will be available in that environment. You do not need to install it separately. So these are the agents which will run your thing. And then let's say you are worried about or you wanted to query what is your operating system, whether it is uh, whether this will return you Mac OS or Linux or Windows. It depends on which environment you are working. Okay, so this can return you that value. So this is nothing but you have not defined it. Wherever you are running, so that environment or that particular operating system will be given. So these are system variables. Like you wanted to know where are you working? What is your default working directory? So you say system.default working directory. It will give you a value wherever you are on this particular agent. Hmm? And also there is some user defined. You have yourself defined the variables. User defined variables. That means customized. It is for your uh, need of your pipeline script. You have defined few variables, and these are called user defined variables. Like you are saying, see, always it will be key colon value. So what you are saying, multiple values or multiple variables. So you say variables and you give curly braces. Curly braces. Within the curly braces, you are saying one variable. So variable var1 colon some value comma var2. Let's say I'm giving it a name. Don't give equal. You are defining. So you can define 20 variables like that, but within the curly braces. Okay, if you want to define one variable one by one, so you can say what is the variable name. So let's say the variable name is a name. It will be camel casing. So if you say last name, so it can be last underscore name. So this is the camel casing, or you can define last name as the key value as small last, and there is no gap or no dash. You cannot give gap last name. So this is a camel casing. You will learn this in details whenever you learn in details, but the scope is limited for me to define all these things. These are nomenclatures. So this is called camel casing. So there are two words separated. The second word will always start with a capital. Then colon. Say my last name is Paul. So this is the value. This is the key value pair. But if you had to define, say, name is Debasis, or you can say first name, first underscore name. See, if I have to give two capitals, then please separate them with a underscore, no dash, underscore. So F can be in that case. But if you make it together, two different words, then you start with a small letter. For F must be small and N must be capital. Anyway, that is the convention, Debasis. So, but if you have to club them together, so you will say name, or you can say full name, you say colon. This is the just JSON way of doing it. Give a this thing curly braces, and then you say first name colon Debashish, comma, last name colon Pal, Pal. Are you getting me? Anyone? So the key is full name. So whenever you are referring to this full name, what will be the value displayed? So how will you refer to that? You will say full name dot what? Anyone? First name. And then you say full name, sorry, dot. This will be a single dot. You are referring to this particular collection. This is a collection data. So your full name dot what? What will be there? Last name. So what will this return? What will this return? Anyone? What will this return as a value? What will be the value of this? It will be Debashish without the double quotes. And what will this return?
Last name.
Yes, last name, Paul, without double
Paul.
quotes. Are you getting me?
Mm-hmm.
So this is, but this is a user defined. So you can have your whatever the name that you define, but you cannot change these ones. These are already defined. You have to give it correctly. So there is the whole lot of documentation is there. You don't have to remember anything. See, there is in IT, you do not have to memorize anything. You need to know where will you get all these things. So there is the Azure DevOps documentation. You go there and look for Azure DevOps predefined variables. Immediately this document will bring up, and you will say within that you want to get all the build variables. There are hundreds of build variables, out of which one is the build number. So you will open up. So another, you wanted to see what is the system variables. So it will open up a document having all the list of all the system defined variables. So these are default working directory, one of them. That way, you do not need to remember anything. Whatever you need, you will just use it. That's all. Variable groups and secret variables. These are secret variables which are defined to store your passwords, tokens without. And so if you want to mask anything, something in the log, some variable with a value is coming with a log. So you do not basically want it to show up your variable name. You want to mask it. So these are you can define within whenever you define it as a secret variable. Okay. Any questions? So configuring build agents. As I told you, the agents are very important. Why? Because if you have to work in an organization, you must have a very clear-cut definition. Whenever you are going to talk to your architects, or solution designers, as a DevOps engineer, you need to talk to so many people. Okay. Uh, Designers, architects, developers, testers, project managers. So they will have their own jargons, own way of talking, some language they will talk. Now, whenever you are talking about the pipeline, they will talk about agents. They will ask Devashish, what is the agent that you are using in your pipeline? You say, I'm using Microsoft hosted agents. They will say, okay, Devashish, we have a very, very specialized type of an environment. Can you enable Microsoft hosted agent? Because Microsoft have their own environment. Okay, so you will say, okay, in that case, we will go for self-hosted agents. Because we want to customize, we will have our own environment set up, a very specialized type of environment, specialized build environment. So we need our self-hosted. So we will not go for Microsoft hosted agents. But when we learn to write pipelines, it is better we use Microsoft hosted, because otherwise this is a server that is within our organization. We will have to install all the softwares, related softwares for the build, for anything. So for .NET programs, you will have to install NuGet from Microsoft. For Java, for the jar, okay, you will need to have the Java compiler. For Python, you have to have your PyCharm or something like that. You have to install all those. Instead of that, if you need to have all the popular compilers and softwares, you can go for, initially you must go for Microsoft host, because everything and anything that you need, if it is not very specialized environment, you can always go for, this is a very popular thing. That is why Azure DevOps is so popular. Whatever you need, it is already available. You need to have Terraform. Okay, it is there as a service already installed within the Microsoft hosted. You do not need to install Terraform. You do not need to install Ansible. Okay, you just have to have a service connection to this particular service or software with the pipeline. That's all. Are you getting me? What is the difference between Microsoft hosted agents and the self-hosted? This agent pools we will create if you have, if you want to do something in parallel processing. You want this job 1, job 2, job 3 to run in parallel, not in sequence. In sequence means job 1 will run first. There is a dependency. Unless and until job 1 completes, job 2 will not start. Then job 3. Okay. So if you do not want a sequential jobs, you want parallel jobs, you need to have multiple agents at the same time. One agent will not do. So you can build up an agent pool. But generally, to start with, we are very good with, because these are very, fast. Pipelines are very fast. So you do not need to worry. And most of the jobs, you remember, 90% of your jobs are all sequential. I mean, there will be some dependency. Yeah, few of them might be like this. There is job 4. Job 4 will have a dependency. You will set a dependency that unless job 2 and job 3 have not completed, you cannot start job 4. Or maybe that job 5 is there, but job 5 will only start when the job 1 and job 4 have started parallelly. So let's say job 1 is a parallel job and with job 4. Job 1 and job 4 starts together. And job 5 has a dependency that whenever job 1 and job 4 has completed, then only it will start job 5. Okay, so job 4 does not have any dependency on anything. Job 1 does not have any dependency on anything because they are starting points. They are parallel jobs. Whereas job 2 depends on job 1. Job 3 depends on job 2. Uh, Job 5 depends on job 1 and job 4 to have been completed. It does not completely depend on job 1 to be completed or job 4 to be completed. It needs both this job 1 and job 4 to be completed. Are you getting me? So in these cases, when you need to run two parallel jobs, you need agent pools. Any questions? So basic build tasks. What are the build? So uh, you have integrated your source code. Okay. So from the GitHub, which has the developer has put in some source code over here in the build uh, in the GitHub. And the pipeline, in the pipeline, you have a trigger point. So any branch you have designated, on that branch, something has come from the developer. Some something has been merged into that, some commit, some changes have happened. Okay, immediately you have triggered your pipeline. So you have integrated, this is called CI, continuously integrating all the changes into a desired or a designated branch. So it has come to integrated with the pipeline. So the pipeline starts. This is the starting point. That is called checking out of the code. This is checkout of the code that will happen automatically once you trigger the pipeline. The pipeline will integrate the code within the after there is a activity over there. So this is called checking out of the code. This is the first step in any build pipeline. Okay. So after that, you will restore the dependencies. That means there can be some dependencies. Most applications rely on external libraries and packages. So you will integrate those libraries into the code. So there will be a build server. With the pipeline will hit the build server for building up. So integrating all the libraries that are, so there is some sort of dependencies, like you get the NuGet restore, npm install. This is for, npm is for your backend processing or backend install of your Node.js. So whatever JavaScript or there are many applications like the React.js, React Native, or Angular. These are front ends, very popular software, Angular, Vue. Okay, so they need the Node.js server. So how will you integrate them? You will have to get that libraries. So npm install, you will install that npm. NuGet is for the .NET from Microsoft. Or pip is for the Python. So you have the Python applications. So you must have these libraries from the pip. So these are the dependent libraries for your applications that the developer has put in this as a source code. Okay. These are all required dependencies available before building. So you have to ensure your environment is already available with these particular these respective libraries. Any questions up to this? So we are going step by step. Before you build, you need to integrate or have this particular things installed. If you want to have the jar files, the Java files, you have to have the Java compiler libraries, Java libraries in integration path. After that, you start building the application over the build server or particular thing. So you will have MS Build, Microsoft Build, Maven, Gradle, or any language specific compilers. Okay, so that will build your uh, build your application. And that build that build will happen, and it will create the artifacts for publishing, for deploying. For packaging, you need to get the packaged artifacts. Package the build outputs into deployable artifacts, because you cannot. There are hundreds of files, hundreds of source code Java files. Can you separately deploy each and every file? No, that is no meaning. You have to compile it in one artifact called jar file, jar or var file, isn't it? Or you say NuGet. All the .NET files will be compiled into a NuGet file, or Py files for Python. So those are artifacts which will be stored into an artifactory, and which this is nice for packaging, which might involve creating zip files, Docker images, NuGet, as I told you, NuGet, and other distributed formats. It can be jar, it can be var, it can be Py. In any distribution format, this will be in form of artifacts available in the artifactory. Is there any questions? So these are the various: check out the code, restore the dependencies, build the application, and create the artifacts. That is, you package it for release, for delivery and deployment. Any questions? Any questions up till now? No? So let us continue. So running the test in the pipeline. This is not a very important part for a DevOps engineer to be, but if you are aware of it, it's good. So there are types of tests called unit tests. Before you give it to the final testing, you must unit test. So there are execute the tests that verify with individual components. But the advantage of using a pipeline like Azure DevOps is that there are built-in framework. Like it is already having VS test for .NET programs, Zest for JavaScript, PyTest for Python. Okay, so there are hundreds of other test libraries. So you can use the third-party tools within the framework of Azure DevOps to easily run and configure the test. These are to configure the test runners to generate results in a format Azure pipelines can interpret, that it can pass. Yeah, this I'm finding correct. The unit test has passed. So automated testing is one of the important. It is the cornerstone of any CI/CD pipeline. But how good is your automated testing depends on how good is your pipeline, from which vendor it is coming. Then you go to the very important part called SIT, integration test. Now this is the testing department are experts. As a DevOps engineer, you might be helping your developers with the unit test, but this is a specialized area, SIT. This is specifically with the testing team, that is the operations team. This is called the quality assurance team, operations. Okay, so verify interactions between components and external systems. These often require specialized setups to prepare test environments, databases, or mock services before execution. Code coverage. Now, most of the things, it will measure how much of the code you have covered within the test purview, test domain. So whether you are covering 60% of code or 80% or more than 80%. Now, generally, there is a threshold that is defined by each company, that if you are not covering your uh, test cases to cover 80% at least of the code, then it will not be passing. If you are only covering 60%, no, it will not pass the code coverage. You have to design your test cases much more in detail such that it can cover 80% of the code coverage. Then it will pass. So this will automatically be taken care within the pipeline. That is why you use some pipeline like this. Code analysis and quality gates. So as I told you the other day, there are Sonar Cube. You can integrate your pipeline, the code, to go through the Sonar Cube integration. Sonar Cube. So there are tasks, inbuilt tasks with the Sonar Cube provides a comprehensive code quality analysis, detecting bugs, vulnerabilities, code and smells. Okay. So Azure pipeline can easily integrate seamlessly with Sonar Cube. It's very, very simple. If I can, if generally in our job ready training, we go into details of all these things, how you integrate and how easily you can integrate. It seems like a very difficult thing. No, not at all. You can easily do all these things and automatically taken care by in form of tasks. These tasks are specialized service that is provided within like this is a task, a service provided by you just have to configure. There is a form. There is a form. You have to answer few questions and say you have to integrate with the Sonar Cube that you have implemented within the pipeline. That's all. There is a service link to the Sonar Cube and all these things. When you say that this is my service group, this is this thing and that thing, and you name it, configure it, and you are done. You want to prepare, you want to analyze, you want to publish. So all the three tasks can be easily accomplished when you have Sonar Cube in your integration pipeline. Static code. A code can be easily analyzed before it is built. So if you are trying to find if there are any critical issues, so without actually testing anything, you can analyze the code with ESLint, StyleCop, PyLint. Just you use this particular service. It is easily available within Microsoft Azure DevOps. You just have to give a task. This is the key and this is the value. And what is this? This is nothing but I will show you maybe next day that this is just a service that there is a list of services that will be appearing to you, task list, and you will just say that I want the ESLint service. That's all. You say I want configuration to be done. And then you say recommended is fail on error. That means anything that is that there is an error, you will fail the entire test. So if the output is error, because it is true, then you will not pass. The analysis will fail. There is some thing that has to be taken care in the code. Similarly, Sonar Cube. So quality of the code is not good. There is a code smell. It smells. There are vulnerabilities. There are bugs. It does not pass the analysis, quality analysis. There are so many quality parameters it has to pass. So once everything passes, you can define your quality gates. You will say that I can only pass the code when the test pass rate is 95% or greater. Code coverage is 80% or greater. And there are critical bugs. There are nodes. There are zero critical bugs. If there are bugs, but those bugs are soft bugs, or those are non-critical bugs, it's okay. But if they are critical bugs, so you have defined what are the critical bugs. If that has been defined and you have passed, that means there are no critical bugs, your thing has the quality gate will pass. So you see, whenever you are delivering something through the pipeline should ensure you are delivering a, a standard product to the client. So now can you think that how each and every stage you are passing each and every parameter? And but then everything has been set up. Everything is very, very automated. Can you see how much good the quality of the software that you are delivering? You fail at every stage, and that is what you require. You must not fail in the end, you must fail early. That is the essence of DevOps. DevOps is something that you must fail in the very beginning, not failing in the end. That was the difference between uh, so your waterfall method and the agile method. Agile method gives importance to failing in the very early stage of your software development lifecycle. Any question? And now see all the theory that you have learned. Now you are seeing how you implement them over the pipeline. Somebody might ask, Debashish, you are talking so something which is hard to believe or too good to be true. I say no, it is true, because finally when you see, when you learn a software like this, a pipeline, then you see, yes, it is possible to have checks in each and every part of it. Okay. Any question? Okay. Now, so you are building the artifacts. You are building the artifact. So you will define the artifact. It is not basically, it is before you publish the artifacts to, it's basically of the release. In the release pipeline, you will in the release. See how many pipelines you have learned so far? Can anybody tell me what is the pipeline that you have been working with now till this point? What is that you have been working with? You have been, if anybody asks you, you say that I have been working till now with the build pipeline. Okay, this is with the CI and CD. CD is delivery. But now you have to deploy it. Another CD, but this CD is deploy. This is delivery. You have to deliver it to your test server. Now you have to deploy it to your test server. So this is deploy. So you have built it. Now you have also packaged it, but now you have to release it. So there should be a release pipeline. A release pipeline comes into the picture. So what did you do? You have packaged it as well as artifacts. You have packaged it. So you now have to publish those artifacts through a release pipeline, because those artifacts or the artifacts which are after the build will now needs to be deployed into the environment, whether it's a test environment or a pre-production environment or into your production environment. So you will name and version the artifacts like major build or minor patch. Major, minor, these are the various, or you may say release. It depends on your nomenclature. It depends on company to company. Release 0.1. And then that is a draft. You can say draft, or better to say synopsis. Synopsis dot 0.1. After that synopsis, it comes release. After release, it comes your version. When you are actually deploying it onto the production, you give version 1.0. Okay, so naming convention, major, minor, all these things will come as artifact naming and versioning. You will have to publish your artifacts in where? In the Artifactory. Artifactory is a storage that we have said that we have Azure Artifactory, or you can store it in Nexus or in JFrog. You can publish them. So the advantage of publishing them as artifacts is that you can pick it up and then you can release it to the various environments. You can also say, what is your artifact retention time? Whether it is 1 year or 3 months, 9 months, whatever. What is your timeline? Or maybe 5 years. You want to retain those artifacts for several builds. So there is a build life cycle of 5 years. So you have to retain them for 5 years. Any question? So the continuous deployment release pipeline is one release pipeline structure. So organize stages for deployment workflow. You have to define the environment, target deployment environment, whether it's a dev environment or a QA environment, that is the testing environment, or a production or a pre-production environment. And that release pipeline should go through approval process, because this is a stage where you are not coding the pipeline. The coding pipeline comes where? Whenever you code the pipeline, it comes where? The YAML coding, like all the integration, all the shell scripting, the tasks, because those are the steps within the jobs you define. Where do you code it? In which stage you code it? In the build pipeline. In the release pipeline, you have no coding. It is just through your Azure DevOps software, you will just make arrangements for the structure of the pipeline, the release pipeline, and then you will say which environment what are the environment variables that you want to dev, whether it's a dev environment, QA environment, or product, prod or pre-prod. And also you will say that on this trigger points or on these conditions, I would need to get an approval before I do this. For each exit gate means from this phase to that phase, I would need an approval from my project manager or from the client or from the test manager, all these things, manual validation. So you will send a mail, and unless and until that mail comes as an approval, you will not move into the next stage. So the manual validation points before deployment actually, so these are all validation points. I am happy, I am happy, I am not happy. So it will go back to the previous stage. I am happy, I am happy, I am happy. So approval, approval, approval. Each stage it will pass through approvals. So the release pipelines in Azure DevOps define the process of deploying those artifacts that you have built to various environments. Unlike build pipelines, which focus on compiling and testing the code, a release pipeline concentrate on deploying the resulting artifacts to their target destination. These two are distinct pipelines. Build pipeline is how you build the code. How do you configure the pipeline? How do you code the pipeline? Okay, how do you test the code? All these things will happen. All the service that you need to test, to have the Sonar Cube to quality test, and also you will compile and build. So all these things will be done through your pipeline coding. But in the release pipeline, you will design the stages, how you will deploy those artifacts for further testing and testing in different stages. Okay. And how you will give a feedback mechanism back to the developer or the testing and all those stuff. So multi-stage pipelines, you see development, testing, staging. Staging means pre-production. And then you go to the live environment, which is the production. So these are the various stages. So multi-stage pipelines in YAML allow you to, YAML means YAML pipeline, allow you to define your entire CI/CD process in a single file. So you can name that YAML file as your single file. In that file, you can define all the stages. You can have two files. You can have multiple files. One for the build, one for the one for the integration, one for the build, one for the packaging, and one for the release. So maybe four pipelines, four YAML files. But for release pipeline, you will just configure the release. Release pipeline, you do not have any coding. Because you need to know how to deploy, what to deploy, at what conditions to be deployed, with what validation checks need to be deployed to the environment. So one stage can have a dependency on the other stage, ensuring proper sequencing. You see, you can build between the stages, you can build dependencies. You can ensure proper sequencing. You can also implement conditional stage execution. So you can say that unless and until this condition or exit quality gate is met, I will not go to the next stage. You can have the branch filters, custom expression, so many things, but that all belongs to the release pipeline. This is for the build pipeline. And within the build, you can have multiple stages. You can have a single file, or you can decide to have each stage in a single file. So there are 4 stages, so 4 YAML files. That is fine, but I will prefer to go in a single file and I will segregate them: stage 1, stage 2, stage 3, stage 4. I do not need to have one YAML file for this stage, another YAML file for this stage, and onwards. I will have one YAML file having all the stages, multiple stage pipeline. But these are built within the build pipeline. Release pipeline, you do not generate any YAML pipeline because there is no coding part. Is that point clear? Any questions from your end? Unless and until you see a bit of it, you will basically, you might not think. So now we come to the deployment strategies that are the big houses. Whenever I assume that you will be working as a DevOps guy in a big organization. Okay, so there are various deployment strategies, because on a big company that you are working, or a medium-sized company that you are working, there is a number of production servers and number of projects that are running at the same time. There is not only one project or one software that is running in production. There are many. So your new product line, something that you have developed, you must deploy it into the production boxes, but you must be very careful that it does not disturb the one which is running already in the production box. So you can go for a deployment strategy. Strategy of deployment is the one of the most critical path or a critical activity within an organization. Okay, one is called the blue-green deployment. This is a very popular deployment strategy. Comes the canary release. This is the second most popular strategy. Deployment strategy. Feature flag is not popular nowadays because either you go for the blue-green or canary. feature flag used to be a bit older strategy. Rolling deployments is very, very popular as well. It depends on the company policy, what type of release or what type of deployment that you want to do, which is your comfort level to do it, which is your expertise in doing it. So the most popular one is the blue-green deployment. Basically, you maintain two identical environments on the same production box. This is the same production box. This is the live. And this is a new or test environment. But this is you are testing directly on the production. So your new software has been deployed over here. And the live, so all your customers are all connected. So the traffic is connected to this live environment, right? On the production box. No customer, no traffic is diverted to this. So what you do, you deploy your new product into this environment space. Okay. You thoroughly test it. Deploy the new version to the inactive environment. This environment is not active. This is the live environment. Are you getting me? So this, nobody is worried about this because this is the inactive part of the production box. You test thoroughly. Then switch traffic from the active. Now, if your testing is 100% approved, you are very, very happy with all the test cases have passed 100%. You divert the entire traffic from the live in one go into this. So everyone has switched over. So this becomes inactive. So this becomes blue. This is green, right? So the traffic was active on the blue. Now the traffic has been diverted to the green. And the users are transparent. Users do not get any downtime. It happens so seamlessly. You just divert or redirect the traffic over onto the green box. That's all. You are done. If there are no issues, this becomes inactive. This becomes active. Live. This becomes live. So now the next part of the deployment comes over here, not over there, because this is the inactive. This is the inactive. You again do the 100% testing. Then again, you make the green to blue by moving out the traffic from here to here. This way, the blue-green deployment keeps on happening. Are you getting me? This provides instant rollback. Something happens on the live, something is not working properly. You immediately just make the traffic back to this live, back to this. So this becomes live. If you encounter any problems with the traffic or the user experience is a bit bad, here it becomes a bit slower. Immediately what you do, you switch over the traffic over to the older one. So you roll back. It's a very popular blue-green deployment. Canary. So roll out your changes to a small subset of users. So instead of having the entire traffic, this is the 100% traffic switch from the live to the newly created environment, which is tested thoroughly. But here you do 5%, then another 5%. So you move 5%. If you keep on increasing the load. Okay. And if you see that all the 100% and without any impact has been done. So this is what you say canary, small bird. Canary is a very small bird, canary birds. Okay. So you say, I have done a canary sort of a deployment. And here the downtime is very, 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 very less. Here there is no downtime. In fact, immediately you switch over. So you can say few seconds maybe. What it takes to switch off this and switch it on the traffic. That's all. The few seconds delay. Whereas this has potentially no downtime because you are doing it 5%, 5%, 5%. Your traffic does not get impacted. Users don't get impacted. Yes, what you do, if you see that when you increase the load from 5% to 5%, and now you have come to 50% of the load, suddenly some issue comes up. You immediately start rolling it back. Feature flag, that is on and off. You make some features gradually. Out of say 50 features to be deployed, you will make some features, say 5 features on, it's working. Then make another 5 on, it is working. Then another 5. So till you reach 50 on and off. If somewhere you get, after deploying the 5 features, it is not working. So you make all the 5 off. That's all. And rolling deployments. Okay. Update instances of an application incrementally rather than all at once. So incremental deployment. Like you have the incremental backup. What you have already backed up, you should not. You do the another part of the backup which is not available here, and then you keep on adding layers. So these are incremental backups. Similarly, here also you do the incremental deployments rather than all at once. You do not do it at once. This also minimizes the downtime by keeping some instances running. So there are two running instances. Here it is 100% running. Okay. And another server, you have picked up, say 20% of the processes, put it over here, it is running. Then the next 10%. So incremental. Then at one point of time, you will see that this is running 100%, as well as the another server is also running now 100%. So you can switch it off because this is made on. There is no downtime. This is also very, very, and anytime you want to roll back, you just make it from off, you make it on because there is some issues. Right? Any questions? Anyone? Any questions? Are you being able to hear me?
Yeah, audible.
Audible, right?
Yeah.
So are you more or less getting it, what we are trying to
Yes.
achieve?
Yes, I
Very
think
good.
I could understand.
Very good. Thank you. So let us proceed with the rest of the things. I won't be having time enough to show you some demo of something that we have done on so that you can definitely see. Only looking at the theory, you might not understand the entire picture. So better the next day, I will show you a practical demonstration on the software itself, on Azure DevOps itself. So you can relate what you have learned, you can relate on it, right? That will be much more interesting. This is a bit boring, I understand. Yes. So as I told you, Azure DevOps does not do anything on its own, everything. It takes the help of external tools, external services, like you can integrate with the GitHub, and you need to. because GitHub is a place where your developers will put all the code. So a GitHub integration is very much needed. Then uh, two pipelines can work. You already have a pipeline already running on Jenkins. Okay, but you want to implement another part because Jenkins does not have a release pipeline. So maybe, or maybe you want to do another pipeline with Azure DevOps. So you can integrate between two pipelines. One, Jenkins, let it run with whatever the old pipeline structure it has. Let it run. I don't want to disturb it, but I will integrate with that Jenkins pipeline, take its output, take it as an input over the new pipeline that I've built over Azure DevOps, and carry on forward that, because Azure DevOps is much more advanced than Jenkins. Then I can use Docker images, because many of the nowadays, or most of the deployments are through the Docker images, containerized deployment. Okay, so we will try to integrate with the Docker Hub or Azure Container Registry. So all these things where you store your images, the Docker images, application images. Okay, so these integrations are very, very important, and this can be done. I can assure you, these are done like a cakewalk. It is like easy, very easy. You take it from me. These are very easy. So like I was saying about the parallel jobs, right? So you see, this is the jobs. This is the job key, jobs, the clause. Within that, there are two jobs. Can anybody tell me, is this a sequential job, build front end and build back end, or it's a parallel job? I mean to say, can you ensure that build front end will work first, complete, and then build back end will start? By looking at this particular script, do you understand that? Do you say that this is a parallel pipeline, or a parallel jobs, or a sequential job?
It seems to be parallel.
It has to be parallel, because as I see from the very structure of these jobs, these two
Mm.
jobs within the job, they don't have any dependency.
Mm.
Did I build any dependency between the build front end, this job, and this job build backend? Did I do any dependency? No. They are two independent jobs. They are using a script, a step, which is the activity that actually what is happening, the task. The task is defined as that there is some Node.js application, like say, there is some front end application which has to be built with NPM. Okay, so I say, just see how simple it is. I will entirely build this entire application, the front end application. Let's say it's a Angular application, or a React JS, or a React Native application. I will use the NPM build to set up the environment. All the libraries, I will attach it. Okay, and then this is a build backend. So there is a .NET program which needs to be there, but that will be a different job. There is no dependency between this and this, so therefore they will start together. Which one will start first? I have no control. That will depend on what? Can anybody tell me? Who will decide which one will start first? It can start together at the very same time. But who will decide that, or who will take care of that? Who runs the job? Some technical term. Did we not learn something like called agents?
Yes.
Agent. So what is the one agent? That is shared. This is mostly used because it is given by Microsoft. And the other one is self-hosted. That is, you have your specific or your customized environment that you need to build. Okay. So you say, I will build my self-hosted agent. I will have my own customized your applications or compilers. Okay. So I need a specific environment for myself. So this is my server. I will install I will build my own environment, whereas this environment is already built for you. You just have to use it. So this basically is the .NET or the NPM. This is running on an agent. So this job is running on an agent. It can be anything. It can be shared or it can be a self-hosted. Doesn't matter. Or you can redirect to an agent pool. In that agent pool, maybe this particular NPM is on a self-hosted agent. You can redirect it. Or this one .NET is on a Microsoft hosted agent or shared agent. Because I did not install .NET compilers, which is the Microsoft compilers over here. Microsoft compilers are definitely available on the Microsoft shared server agent. Okay. So this can be in a pool of agents. Or to make it simple, you can have both of these jobs running on a particular shared Microsoft or self-hosted server agent. Is that clear? Then again, you can have a matrix strategy. Say a job test. What is the strategy? Strategy is that on a matrix which runs on either Windows or Linux or Mac OS. So you are saying that if it is Windows, the operating system is Windows latest. If it is Linux, if the framework needs to be, see, if the framework is all .NET, okay, .NET 6.0, but they are available on OS if you are using a Windows environment. Okay, if your application is built over Windows, you need a Windows OS, or if the application was built over Linux, you need Ubuntu latest. Latest is the image. These are called the images. It can be a Docker image. This is available in the Docker Hub or Azure hosted server. Okay, as Azure repository, Azure registry, sorry, image. And Mac OS, if it is a Mac built application, it will use the image of Mac OS latest. So this is the OS operating system. So you just define the strategy. And then you can have a pool. You are defining the pool, that is this one. So that means that your VM image, these are all keywords, YAML keywords that is given by your Azure DevOps. So you say you have defined a variable called OS. Now what this is a dollar to interpolate. So this OS will depend on whether if you are working on Windows environment, this will be the value will be this. If it is, it cannot have all the three values. No. So either you are working on Windows or you are working on Ubuntu or you are working on Mac OS. Are you getting me? Because this is the strategy that you have adopted for your testing. Okay. So your test box, you are testing the same application, but you are one time testing on Windows box, test box, or maybe you are testing on Linux, because you do not know your client might be working on Linux. So your application should be working on Linux, or your client might be working on Mac OS. Mac OS. You do not know, but you must be ready to port your application on any of the environments or platforms that is ready. So you must test it in all three of them. So you change after Windows testing has passed, you change it to Linux. Linux have passed. You change it to Mac OS. So the entire test has passed. That is your strategy. You do not need to change the YAML file, the pipeline script at all. It will adapt to the basically what OS you are using over here. That's all. So the script is .NET test, and the framework is the framework that you are using. The framework is this or this or this. So this is the script. That is the step. That is actual. This is the part. This is the shell script. If you are using a .NET program or a .NET compiler, you will see that this is the syntax of .NET. You are compiling a .NET source code. So container-based CI/CD, you see, why I put this slide for your understanding is that most of your applications that you will be building and you will be packaging it within as a Docker image. So somebody will write a Docker file, container build instruction. So you will say how you will build your application. How do you package it? So you will package it as a Docker image. Whenever you run this Docker file, you will get that image into a Docker image. You will build it as a Docker image. And after that, you can either deploy it to serverless container hosting or for simple workloads, but generally you will do it to deploy it to the Kubernetes deployments. So, but the base image, this is the base image. This is the base image. So this image, either you deploy it over Azure container instances, or basically you deploy it to a containerized, so Kubernetes deployment, Kubernetes orchestration, orchestrated container management. So these are the things that you learn in your DevOps course. What is Kubernetes? What is this? But I will tell you, we are also trying to give you some concept of Kubernetes after we have done our DevOps, Azure DevOps. So there will be 2 sessions meant for Kubernetes. If it needs 3, I will do it for 3. So some concept you will definitely get. But here what you do is container-based CI/CD streamlines, deployment by packaging applications and their dependencies into a portable container image. If you do not know Docker, it will be a bit difficult for you to understand what you are doing. Basically, you are putting the entire source code, making it, packaging it as a Docker image so that there is one image containing the entire source code. Whether it's a Java application or a .NET application or a Python application or a Laravel application, whatever it is, you are, it's a PHP application, you are putting that as a Docker image. And the Docker image is very simple. It can be deployed over a Kubernetes architecture. So this is the container based, and the entire thing you are going to do it over the packaging, the building, okay, and then deploying it all on the CI/CD pipeline. Testing strategies in CI/CD. Let me check how many time we have left with another half an hour. Okay, so we can say automated UI testing, unit testing. So you will verify the application functionality through the user interface using tools like Selenium. Selenium is a very popular tool, testing tool. So you will subject your entire source code into, so you will configure Selenium for some test cases that you need to do to pass that particular code. Okay, so use Selenium. So automatically the testing will happen. Unit testing will happen with the help of Selenium. Then you can also integrate your security testing within the pipeline. How? Integrate security scanning. So there is the scanning tools like the SAST tools, static application security testing scanners or tools to analyze the code for security flaws. So if there are security vulnerabilities, that is for the static application security testing, or you can apply the dynamic DAST, dynamic application security. So when you learn cybersecurity, you will know these terms. But you can provide all those tools, scanning tools within the pipeline, and can check the vulnerabilities. Like let's say for dynamic tool testing, you can use the SQL injection. This is a very, very vulnerable sort of injection. So there can be a lot of leaks. So anybody can come and hack through your leaks into your code. So if somebody can get into your data, into your database, that's all, you are gone. So if your code has SQL injection, which is a very, very vulnerable sort of hacking point, you should test it that there is nothing called SQL injection into your code. Okay. Load and performance testing. You can evaluate application behavior under expected and peak load conditions. Tools like, so Azure DevOps has given you tools like Azure load testing. You do not need to buy load testing tools from outside. So it can, like the JMeter or Gatling. Gatling is also very popular nowadays. So these can simulate hundreds or thousands of concurrent users. You have only one single user, but as if at one instance you can generate thousands of users running into your application. So there is a lot of load into your application. All this can be simulated, and you can do a load and performance testing. Chaos engineering. So you will deliberately introduce failures to your test system resilience. So you will see how much your system can take. You will introduce failures intentionally, and you will see how much is your capacity or resilience to take those failures. By simulating services going down, so something like network has gone down, latency has gone up. Okay, so these can all be introduced into your deliberate introduction of failures, and then you can test how much resilient your software is. Or resource constraint. So you have, there were 16 CPUs when you started initial test. Now gradually you are taking off one by one the CPUs. So you have come from 16 to 8. Is your performance degrading like hell? Or still your system is performing at the same level when it was a 16 CPUs? So how dynamically it can optimize according to the resources it is having in hand. All this can be verified and tested. That is called chaos engineering. You are creating some chaos into the environment, and you are checking whether you are verifying whether your application can gracefully handle unexpected surge in conditions and maintains reliability. How reliable is your software? All these things are very, very important consideration before you deliver your software for production. Pipeline automation optimization. This is the most popular one, caching strategy. How good is your caching strategy? If you are good in this, You do not need task grouping, pipeline decorators, incremental builds. Caching is a very important one. So within the pipeline, if you can implement caching to avoid, because something you have to download, why don't you do something that you should not enable it to download again and again that you are hitting that particular part of the code? No need. The same thing has been downloaded once, you must cache it such that this is not required for the jobs, because the job can pick up the downloaded piece of library or code from already cached one, from the cache. This is the cache. So if your caching is Redis, so there is a tool called Redis with which you can do a very good caching. But anyway, so all these things you can implement within your pipeline. Like NPM. So common caching targets include package manager caches like npm, NuGet, Maven. So Maven, whenever you are using the Maven build, it will look into the cache, and it does not need to download every time the libraries that it needs to build. No, it will look into the cache, and if it is already cached properly, it will just pick it up from the memory, the live memory. It will be very fast. The build will be fast. That is what is needed. After all, everything that you are doing, automation is good, but due to automation, you should not compromise on the performance. It should be your pipeline, your process need to be optimized. And caching strategy is one of the important consideration. This is the end of the slides. I mean, if you understand all this part, I mean, theory part of the pipeline, CI/CD pipeline, Azure DevOps has lot of things, and you will just get excited to work over a tool like that. And you can become a very powerful contributor to your company, to your company's processes. You become a fantastic DevOps engineer. Just learning a pipeline tool properly. You, you will be very much in demand in your job, in your company, in your organization. I can assure you. So next day, that is next Saturday, I will just have a demo. I will not build anything from scratch. I will just show you what are the things that we have discussed, how it works, and all those stuff. Is that fine with you?
Yes.
Very good. Because the last 2 days we have just worked with our building up of the concept. And that concept, if I don't have that concept built properly, what happens is when we actually try to do it hands-on, you will face a lot of difficulty. So I always, to me, what important thing is to learn the concepts properly. If you do not have the concepts, you will do it mechanically. If you get stuck, you will not come out of it. You will find it very difficult to come out of the position. And in IT, you must be assured that you will get stuck now and then, every now and then. There is no stopping of that. Even the 20 years experienced guy can get stuck. There will be issues. Every day there will be new issues. Don't get panicked over issues. Issues will come. But if your concept, if your knowledge is perfect, you know how to wade around that particular problem, how to get around with that problem and get a solution of that problem. It is there. Surely you can do that. Okay, I will stop my recording. I will stop my camera, stop my sharing, and stop the recording. It must be very tiring for you to attend 2 sessions consecutively. I thank you for that. So we end the session over here. Thank you for your patience. Thank you for everything. So we will meet again tomorrow, not tomorrow,
Thank you,
sorry.
sir.
Yeah, yeah. We will meet again on next Saturday, same time.
Thank you for the session. Thank you.
Thank you. Thank you very much. Thank you.